Okay, this video is on exponential probability, and according to Discount Tire Direct, the estimated life expectancy of a tire is 6 years. Assume that this life expectancy follows the exponential probability distribution. What is the probability that a randomly selected tire will have a life expectancy of more than 5 years? So when we're doing exponential probability, our formula is just a little bit different from the formulas we've used in the past. So I've pulled up the slide here, and let's take a look at it before we work this problem. So when do we use exponential probability? This is used when we're trying to measure the time between events. So like if we're trying to measure the time between customer arrivals or the time between business failures, we're going to use this. So here we're measuring the time that the tire lasts. And so here we have this symbol, and it is the mean number of occurrences over an interval. So when you see that symbol, it's the mean, but it's the mean over an interval. So here our interval would be one tire over how long that tire lasts. So it would be 6 years. So it's the number of occurrences. So here is our occurrence, one tire over an interval, and our interval is 6 years. And then we can change that to a decimal. And I think I rounded to the 4th decimal place. So there is our mean over the interval. So to find the probability that it will have a life expectancy of more than 5 years, let's look at that. I'm not sure why miles is on there. It should be more than 5 years. So let's work this one. So we're looking for the probability that X is more than, greater than A. So what is A here? A is going to be 5. So the formula we're going to use, let's look at it. If we were looking at less than, or now this is a little bit different. If we were looking at less than or equal to, we would say 1 minus the probability, or 1 minus E. But since we're doing greater than, we don't have to subtract from 1. So this is a little bit different, because usually when we're doing greater than with normal probability, we say 1 minus what we get in the table. But here it's actually the opposite. So we're not going to do 1 minus since it's less than, since it's greater than. We're just going to do, and I'm going to make this a little bit smaller so I can write. We're going to do E, and then the formula is E to the negative A, and then times the mean number of occurrences. So when we're doing E, we're going to use, and if you look in the PowerPoint, we're going to use 2.71828, and then the negative A, we know A is 5, and then the mean over the interval is 0.1 1667. And then if you plug that into your calculator, the probability that x is greater than 5, you should get 0.4345 for your answer. So that would be how you would do exponential probability when it is greater than. If it had been less than or equal to, the only difference would be we would have one more step. If it was the probability that x is less than or equal to, we would have to do 1 minus 0.4345. That would be the only difference. Let me know if you have any questions.